Imagine a lone spacecraft dwarfed by the immensity of space. It drifts silently, a tiny speck in the vast, dark expanse, surrounded by the twinkling lights of distant stars. This spacecraft represents humanity's bold leap into the unknown, a symbol of our relentless quest for discovery and progress. It maneuvers closer to a giant, metallic asteroid, its surface shimmering with untold riches. These asteroids, often considered mere space debris, are in fact treasure troves of precious metals and minerals. They contain elements like platinum, gold, and rare earth metals, which are essential for our modern technology and industry. This is not science fiction. This is the future of space mining. Advanced technologies are being developed to make this vision a reality. Robotic miners, autonomous spacecraft, and sophisticated extraction techniques are all part of this groundbreaking endeavor. The dream of harvesting resources from space is closer than ever before. We are on the verge of a new era, one where we look beyond Earth to harvest resources from celestial bodies. This new frontier promises to revolutionize our approach to resource management and sustainability. By tapping into the vast wealth of the cosmos, we can reduce our dependence on Earth's limited resources and mitigate the environmental impact of traditional mining practices. The potential is enormous, offering solutions to our planet's dwindling resources and fueling our ambitions for further exploration. Imagine a future where space mining not only provides the raw materials needed for technological advancement, but also supports the construction of space habitats and colonies. This could pave the way for humanity to become a multi-planetary species. This is not just about mining for minerals, it's about securing our future. The resources obtained from space could be used to build and sustain new habitats, create advanced technologies, and even support life on other planets. The possibilities are limitless, and the benefits could extend far beyond our current imagination. It's about securing our future. As we continue to deplete Earth's resources, the need for alternative sources becomes increasingly urgent. Space mining offers a viable solution, providing a sustainable way to meet the growing demands of our global population. Earth's resources are finite, and we are consuming them at an alarming rate. Deforestation, pollution, and the depletion of natural resources are all consequences of our insatiable appetite for growth and development. If we do not find alternative sources of raw materials, we risk facing severe shortages and environmental crises in the near future. Population growth and technological advancements are placing unprecedented demands on our planet. As cities expand and technology evolves, the need for resources continues to escalate. This puts immense pressure on our environment, leading to habitat destruction, loss of biodiversity, and increased carbon emissions. We need a new source of raw materials, and the cosmos holds the answer. The vastness of space offers an abundance of untapped resources, waiting to be discovered and utilized. By turning our gaze to the stars, we can unlock a new era of prosperity and sustainability for future generations. The journey to space mining is not just a technological challenge, it is a testament to human ingenuity and our unyielding spirit of exploration. Our planet is a treasure trove of resources, but this treasure chest is not bottomless. We are extracting minerals, metals, and fuels at an unsustainable rate. The consequences are already being felt: resource depletion, environmental degradation, and geopolitical tensions. The demand for rare earth elements, essential for our electronics and green technologies, is skyrocketing. Traditional mining methods are becoming increasingly costly and environmentally damaging. We need a paradigm shift in how we acquire resources. Space mining presents a bold solution. Asteroids, the remnants of our solar system's formation, are packed with valuable resources. These space rocks contain vast quantities of metals, minerals, and even water ice. Mining asteroids could provide us with an almost inexhaustible supply of raw materials, alleviating pressure on Earth's resources. It's about creating a sustainable future for humanity. Section 4. The Space Mining Players. The race to mine asteroids is heating up, with both private companies and government agencies vying for a piece of the cosmic pie. Companies like Planetary Resources and Deep Space Industries are developing innovative technologies for asteroid prospecting and resource extraction. Spacefaring nations are also investing heavily in space mining research and development. This is a global endeavor, with the potential to reshape the geopolitical landscape. Section 5. Technological Leaps and Bounds. Space mining is not without its challenges. It requires overcoming significant technological hurdles. We need to develop spacecraft capable of traveling to and interacting with asteroids. We need advanced robotics and automation for resource extraction and processing in the harsh environment of space. New propulsion systems, power sources, and life support systems are crucial for long-duration missions. Fortunately, advancements in fields like robotics, artificial intelligence, and materials science are paving the way for a new generation of space mining technologies. Section 6. Cosmic Treasure Trove, Asteroids and Their Riches. Not all asteroids are created equal. These celestial bodies, remnants from the early solar system, vary widely in their characteristics and potential value. They come in different types, each with its own unique composition and resource potential. Some are rocky, others metallic, and some even contain water ice. C-type asteroids, the most common, are rich in carbon-based compounds, including water ice, which can be used for rocket propellant and life support. This makes them incredibly valuable for future space missions, as they could provide essential resources for sustaining human life and fueling spacecraft. S-type asteroids contain significant amounts of metals like nickel, iron, and cobalt, essential for construction and manufacturing. These metals are crucial for building infrastructure both in space and on Earth, making S-type asteroids a prime target for mining operations. The rarest, M-type asteroids are veritable metal mines, harboring vast quantities of precious metals like platinum and gold. These metals are not only valuable for their economic worth but also for their use in advanced technologies and electronics. Understanding the composition of these celestial bodies is crucial for targeting the most resource-rich asteroids. Scientists use a variety of methods to analyze asteroid samples and scan their compositions, including spectroscopy and space missions. By studying these asteroids, we can identify which ones hold the most promise for future mining endeavors. The process of mining asteroids involves sending spacecraft to land on these celestial bodies and collect samples. These missions are complex and require advanced technology, but the potential rewards are immense. By extracting resources from asteroids, we can reduce our dependence on Earth's finite resources and support the growth of a space-based economy. The economic potential of asteroid mining is staggering. Some estimates suggest that a single asteroid could contain trillions of dollars worth of resources. This could revolutionize industries and economies, providing a new frontier for wealth and development. In the future, the resources obtained from asteroids could be used to build space colonies and habitats, supporting human life beyond Earth. This vision of a spacefaring civilization relies heavily on the successful exploitation of asteroid resources. Scientists and engineers are continually developing new technologies to make asteroid mining more feasible and efficient. From robotic mining equipment to advanced propulsion systems, these innovations are paving the way for a new era of space exploration and resource utilization. As we look to the stars, asteroids represent a treasure trove of untapped potential. By harnessing their riches, we can unlock new possibilities for humanity and ensure a sustainable future both on Earth and in space. Section 7. Space Law. Who owns the final frontier? The legal aspects of space mining are complex and still evolving. As humanity ventures further into the cosmos, the question of who owns the final frontier becomes increasingly significant. The legal framework governing space activities is still in its infancy, and many issues remain unresolved. The 1967 Outer Space Treaty, the cornerstone of international space law, prohibits national appropriation of celestial bodies. This treaty, signed by over 100 countries, establishes that outer space, including the moon and other celestial bodies, is the province of all humankind. It emphasizes that space exploration should be conducted for the benefit of all countries, irrespective of their degree of economic or scientific development. However, it does not explicitly address the commercial exploitation of space resources. This omission has led to significant debate and differing interpretations among legal experts, policymakers, and private enterprises. The rapid advancement of space technology has outpaced the development of corresponding legal frameworks, creating a legal gray area. This ambiguity has led to differing interpretations and calls for a new legal framework. Some nations have enacted their own laws to regulate space mining, but these national laws often conflict with the principles of the Outer Space Treaty. The lack of a unified international approach has resulted in a fragmented legal landscape. Some argue that space resources should be considered a global commons, managed collectively by the international community. They believe that the benefits derived from space mining should be shared equitably among all nations, particularly those that lack the technological capabilities to engage in space activities themselves, while others advocate for the right of private companies to claim ownership of extracted resources. Proponents of this view argue that granting property rights to private entities will incentivize investment and innovation in space exploration and resource extraction. They believe that a market-driven approach will lead to more efficient and rapid development of space resources. Establishing clear legal guidelines is essential for the responsible and sustainable development of space mining. Without a coherent legal framework, the potential for conflicts and disputes over space resources is high. International cooperation and dialogue are crucial to developing a comprehensive legal regime that balances the interests of all stakeholders. As we stand on the brink of a new era in space exploration, the question of who owns the final frontier remains one of the most pressing issues facing humanity.